Hello everyone, my name is Marah Hamid and welcome to this session. Today I'll be explaining an introduction to programming, specifically algorithms and flowcharts. So what is the programming phases? There are two programming phases, which is the problem-solving phase and the implementation programming phase. So what is the problem-solving phase? It's an ordered sequence of steps that describes a solution of a problem, and that step-by-step sequence is called an algorithm. So, for everything you need to do a step-by-step. For example, if you're doing a cake, you need a recipe, right? You're going to be preparing for it. So that step-by-step situation is called an algorithm. And here we have the implementation programming phase, which is implementing your program to a programming language. And there are many programming languages. There's C++, C Sharp, Python, Java, and the list goes on. So let's talk more about the problem-solving phase. So when you make an algorithm, which is the step-by-step sequence, you're going to have a conceptual solution and the algorithm, and you're going to be implementing the program of that algorithm. So first, to make that problem solving, you're going to have what's called a pseudocode. So what is a pseudocode? A pseudocode is just like general writing of that program. It's just like an informal way if you're writing that program. It's just like simple English, everyday English. You just planning out that program and then translating it to an algorithm, which is steps. It's just an informal way to develop your algorithm. Next, let's talk about the implementation phase. So, after you actually write your program, you're going to have to design and implement algorithms that your computer can carry out. So, our job as programmers is to accomplish a given objective and then translate the individual step-by-step algorithms into a programming language that the computer can understand. So, after having the pseudocode written and you translating that pseudocode to a step-by-step solution, which is the algorithm, you're going to have that algorithm translated to a programming language on your computer. So let's have an example about pseudocodes and algorithms. Here we have write an algorithm to determine a student's final grade and indicate whether it is passing or failing. The final grade is calculated as the average of 4 marks. So let's write the pseudocode. So here we're going to know what are the inputs that are supposed to be given from the users and the calculation you're supposed to do. So we need to calculate the student final grade. So we have as an input the student grade. Also, we need to have the calculation. So it is the student grade. We have 4 student grades, right? So we're going to have all that student grades divided by 4 to calculate the average. And then we have two possible things that may happen, whether they pass or fail. So we're going to say that if the average is below 50, we're going to print fail. Else, we're going to say if it's above 50, we're going to print pass. So this is the pseudocode, just an informal way to organize that program. Next, you'll have to write your algorithm. So you're going to now translate it to steps. So we have here 3 steps. First, we're going to have the inputs. So let's call the grades M1, M2, M3, and M4. Next, we're going to have step 2, which is our calculation. So we're going to calculate the average M1 plus M2 plus M3 plus M4 divided by 4. And finally, we're going to have our if else statement, which is actually just what we written in here. So if the mark is below 40, we're going to print fail. If it's above, we're going to print pass. Here are the answers of the pseudocode and algorithm. Next, let's learn what is a flow chart. So, in a flow chart, it's like a way you design the flow of your data in a document. So, you actually want to show the sequence of instructions in a single program. So, by using different symbols you'll be drawing, you're going to create a flow chart that has a graphical representation of the sequence of operations of your system or program. Let's learn more about these symbols. So, we have 6 different symbols that can be used in your program. First, oval. So, the oval tells you where is the beginning and where is the end, when to start and when to stop your program. So, in the beginning of your program, you're going to have start, and on the end of your program, you're going to have stop. That's crucial in any program. Next, a parallelogram. So, the parallelogram always has all your inputs. Next, a rectangle. A rectangle always have the mathematical equations. For example, addition, subtraction, multiplication, division, remainders, calculating the average. So yeah, many things can be calculated. For example, if something is bigger or less than something, any calculation you will see it in a rectangle. Next is a diamond, which actually uh, sees what is a decision that goes to branches that can be made. So for example, if, then, and else statements is used in a parallelogram. So if there's one more than one decision that can be made, we can have them in a parallelogram. Next is our hybrid, which always has our outputs. So of course, when we finally have the result that we're pleased about, we're going to have to print it. So when we print the output, we're going to have it in a hybrid. Finally, a flow line, which tells you the logic flow of your program. Alright, let's have an example. Here, in the beginning of any program, we always need to have start. Next, a flow line, and then you're going to have your inputs. So our inputs are M1, M2, M3, and M4. So always have your inputs inside a parallelogram. So our inputs is M1, M2, M3, and M4. Next, we're going to have our step 2, which is a calculation of the grade. So all calculations needs to be in a rectangle, which will be calculating our average. So it will be M1 plus M2 plus M3 plus M4 divided by 4. Next will be your if else statement. So it will be in a diamond. So it's going to be calculating if the grade is less than 50. So there are 2 decisions that may happen. So if yes or no. So if no, the grade is not less than 50, then print in a hybrid the output, which is going to be pass. If yes, the grade is less than 50, then we will have it to print for us fail, which is shown here in our flowchart. Now our program is finally done, so we will have everything connected to an oval again that says stop. Let's try doing another example. Write an algorithm and draw a flowchart to convert the length from feet to length. So in our set of code, we have our inputs, our calculation, and outputs. So here's our algorithm. First of all, we're going to have our oval that says start. Next will be our inputs. That is the length in feet. Next, we will have our calculation, which is the length in centimeter is equal to the length in feet multiplied by 30. Finally, what we need to print will be always in a hybrid. So we're going to print the length in centimeter. And that's it. The program stops here. We're going to have to write stop in an oval, and that's all. Here we have a third example. Write an algorithm and a flowchart that will read the two sides of a rectangle and calculate its area. So, in our set of code, we have the inputs, which is the width and length of a rectangle. Next, we need to calculate the area by multiplying the length and width. Finally, we're going to print the area. So let's try doing our algorithm together. So, in our algorithm, we're going to have steps. Step 1, step 2, and finally step 3. So in step 1, we have our inputs, which is the width and length. In our step 2, we have our calculation, which is the area is equal to the length multiplied by the width. Finally, we want the area printed. So let's do that in a flowchart. First, we start with an oval that says start. Next, we're going to have our parallelogram that has our inputs, which is the width and length. Then we will have our calculation, which is in a rectangle always. Area is equal to the length multiplied to the width. Then we're going to have our outputs in a hybrid, so we can print them. So we're going to print the area. So print A. And finally, our program is done, so we'll have an oval that says stop. So it's as simple as that. Let's have our last example. Write an algorithm and a flowchart that reads two values, determines the largest value, and prints it with an identifying message. So here it asks only for our algorithm. So we have here, let's cut this example down. So it will have two values read, which is our inputs. This is our first step. Then we will have our FL statement, which is determining the largest value. So this is our calculation. Or not really the calculation, it's the calculation and determining, it's like an FL statement. So it's determining whether if it's less or greater than a value, which is the calculation, in an if else statement. Finally, we're having it to print the output in here. So let's do that in a step-by-step algorithm. In our first step, we're going to have our inputs, which is value 1 and value 2. Next, we're having our FL statement that is containing the calculations that we will need. So, in our F situation, we're going to say that the maximum number or the bigger number is value 1. And in our second statement, it will be that the maximum number is value 2. So, if the maximum number was value 1, we wanted to print that the maximum number is value 1. If it wasn't, we're going to have it to print value 2. So, step 3, or in our outputs, so we wanted to print the largest value, which is max. So here's our algorithm. Now let's have it in a flowchart. So first we're going to start with an oval that says start. Next will be a parallelogram that has all the inputs. Next, we're going to have a diamond that has our decisions of the maximum value. So we're going to have branches that has the calculations in a rectangle. So if max was value 1, else max is value 2. So we want to print the maximum value. And that's the end of our program, so we will have another oval that says stop. And here is our algorithm, and that's our flowchart. That's it for today's lecture. Hope you enjoy it. See you next time.